Hey guys, as you might know, Zain Khanani recently got the first sub 1 2x2 average with a time of 0.92. And if you watch his recon vid, you will notice that he used a method called TCBL. TCBL is a subset of the larger CBL method. Some of you may be wondering what the CBL method is. Today I'll be explaining how the method works, some prerequisite methods, the subsets, recognition, number of algs, and the method's history. I'm not a fast tuber by the way, I average only 3.5. I think more qualified tubertulers will make their own videos about CBL in the future that are better and more in depth. Today I'm just making an introduction to it. So what does CLO stand for? First, CBL is corners of both layers, but what does that mean? Let's look at PLO first. So this is a PLO. You permute these two pieces, and you're just permuting the last layer. And then you have PBL, permuting both layers. You can see here that we permuted these white pieces and we permuted these yellow pieces. Can I reverse this? So that's what PBL is. Now CLO, you can think of it as doing LO and PLO in the same step. So instead of doing, so you see there's a left student case we can do, so instead of doing left student and then T-perm, which is LO and PLO, instead you could just do one algorithm, which is CLO. Just do one alg and do LO and PLO in both, and at the same time. CBL is doing OBL and PBL in the same step. For example, this easy case, you can see here, you have this Nicholas case here, and you have another Nicholas case here, from a U2 angle from here. So how you do this alg, like this, and then you solve CBL, you do the CLO on both sides. Let's do an example solve. So you want to get CLO on both sides, but how do you do that? So what is the first step exactly? So the first step is to separate opposite colors into different layers. For example, we're going to have maybe all white on the bottom and all yellow on the top. So for example, I can do in 2 moves, you can have this CLO case, all of the pieces are white, and you have this UCLO case here. If you look at yellow, you can have this pi case. So you're basically separating each of the pieces, and this alg hasn't been generated yet, so I'll just solve it like this. And then you're basically separating the colors, and then afterwards you're going to do the one alg. And some of you guys may be wondering when to learn this method. It is definitely not a method for beginners to just learn, because there's a lot of algs to learn, and in order to learn CBL, you'd want to learn at least CLO, EG, and TCLO. Another method I think can be helpful is LS. I don't think it would be a direct prerequisite, but I think learning LS would make some CBL cases easier to learn, as some CBL cases are one move away from LS. For example, and I'll just do another case. Let's say, you can see here, in this T case, we have one move away, and then we have an LS face, and then we have an LS. So certain LO shapes have one move into an LS, which can be useful. It can make learning algs easier if you know LS already. And I don't know this case. CBL has 4 major subsets. There is CBL neutral or CBL 0, CBL plus, CBL minus, and CBL D. The first 3 sets have 804 algs each, and the last one has 382. Combined, this makes 2,794 algs. That's a hefty amount. What do the different subsets mean? CBL 0 means that the top face has a CLO. If you have a CLO on top, you have a CLO on bottom as well. For example, this case, the Nicholas case again. You can see here there's a CLO on bottom and there's a CLO on top. Wait. Oopsie. Messed up. And CBL plus is when you have a CBL case on top. And for example, that could be it'll be like a hammer. And this is where I said learning TCLO is important, because if you don't know how to recognize TCLO, this method's going to be hard. Because if you don't know this is a hammer case, for example, and this is a Stolari or just a regular TCLO, then you're not going to be able to recognize cases easily unless you decide just to learn all of CBL neutral and not any of the other subsets. That's kind of a bad idea because there's a lot of good cases that you can learn from CBL plus and minus. So you want to learn TCLO first, you can get that recognition. And TCLO minus, as you may guess, is having a TCLO minus case on top. Because of the similarities between CBL plus and CBL minus, there may be times when there's no need to differentiate between them. In that case, you can just call them TCBLs. Now the last set of CBLD is a bit wacky, but if you have the same LO shape on top and the bottom, then you have a CBLD. Like this. For example, we have a T here and then a T here. They're the same CLO case as well. These like matching stickers. They don't need to be the same CLO case, but they just have to be the same LO case. Like these whites make a T, these yellow make a T. So that's an example of a CBLD. And there's a couple reasons why we have this subset, even though this technically could count as a CBL 0 or CBL neutral. Why do we have it as its own subset? One of the reasons is so that CBL 0, CBL plus, and CBL minus have the same number of cases. And there's another concept. The concept that I should mention now is when you're doing CBL, some LO shapes have a higher priority than others. What this means is that when you learn algs by having a higher priority, you can learn algs by having a higher priority LO case on the bottom. For example, for a CBL case with T on one side and SUN on the other, it is customary to have T on the bottom because of its higher priority. Like the reason why we have higher priority for some of these cases is because T, for example, has one move away. Some of them have one move away to LS, and they have more blocks, so they're easy to identify. While stuff like H or Pi, they're harder to identify, so we usually like to have them on top. And what happens though if you have a T on one side and T on the other side? Which one has the priority? Which one do you have on top or bottom? That's another reason why we have CBLD, because of cases like this, where it's too hard to determine the priority. So how to recognize the case is not too hard. You just look at the CLL on top and the CLL on bottom, and then depending on what cases you see, you learn what alg you need to do. Nothing too crazy there. Now what are the benefits of learning CBL? One of them is the low move count in solves. To separate the colors, you only need a maximum of 2 moves, and usually it's like 1 or maybe even 0. So take this case, for example. Let's look around the cube to find some good things. You can have 1 move like this, and then you get this TEG. I mean, yeah, it might just look like a TG if it's not anything cool. But if you look here, it's just a Solari case. If you know TCLO recognition, this is just a Solari case. But if you don't want something that's just like one piece twisted, we could also do some other things. How about something like this? So you can see here that we have this red here, and then we have orange here, and this is gun, this is turtle. And we can do one more example, show you how easy it is to make it. And let's see, look around, because there might be sometimes there's very efficient things that you might. Yeah, there's this one move here, and that's just already does the blue and green axis. We have a U case here, we have a SUN case here. So sometimes you get really like good cases where you can just do 1 move or maybe even 0 moves into, like you might have already pre-made CBL. If you recall from Zane's recon vid, he already had 2 pre-made CBL, so it's not that uncommon to have a CBL already made in the scramble. I'll wrap up with a bit of the method's history. CBL may seem like a big new futuristic thing, but in reality it was made in 2009, albeit under the name Rod and First Layer, or RoFL. It was invented by Stefan, and I have put in the description many of the posts he made relating to RoFL. Some of the algs from Rod and First Layer were used by Chris Olsen and Robert Yao to make TCL, as TCL is a subset of CBL and Rod and First Layer. The name CBL is a lot more recent. It was proposed in the 2x2 solvers Discord around August 2023. The latest development of the method is Zane using it in his 0.92 world record average. Keep in mind that this method is nowhere near completion, and new things will be found. Terminology might update, or maybe how we group the subsets will change. I have linked a spreadsheet of all the CBL algs gens so far. If you have any questions, you can either ask in the comments, or you can join the 2x2 solvers Discord and ask questions in the CBL channel, where you're more likely to have your question answered by top 2 RA2ers. That's all for now. Have a good day.